All right, here's our last video for this section about power series and then finding radius and intervals of convergence. We're going to find the interval of convergence for letter B here. Just as an aside, and well, not an aside, but just to get us started, what would be the center of this power series? Well, we're supposed to look at this and ask ourselves, what are we subtracting from x? Well, we're subtracting -1. And if -1 is what we're subtracting, then that would be the center is -1. So we're going to come back to that idea here in a little bit. But we're going to go ahead and do the limit as n approaches infinity of the absolute value. We're going to do the n plus 1th term. That would be this times x plus 1 to the n plus 1, all divided by 2 to the n plus 1. Okay? And I'm going to divide that by the nth term, but I can't really divide fractions, so we're going to multiply by the reciprocal. That's how we divide fractions. And we're going to make that be less than 1 because we want to make it converge. Is there anything that we can reduce? Well, yes, I think I can reduce this with this. I'm still left with -1 to the 1 power. I can reduce 2 to the n and 2 to the n here, but I'm still left with 2 to the 1 power. And I can reduce x plus 1 to the n with x plus 1 to the n, and I'm still left with x plus 1 to the nth power. So let's see. What is left over? Absolute value of -1 times x plus 1 divided by 2, and that's it. Take the absolute value and make it less than 1. Okay. I think I got everybody. Yes, 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 yes. Okay. Well, the absolute value of -1 is going to be +1, so I can kind of make that disappear. And now I'm going to take the limit. Well, the limit is as n approaches infinity, there are no n's. So therefore, I'm just going to take the absolute value of x plus 1 divided by 2, and that's going to be less than 1. Well, when is that less than 1? Whenever -1 is less than the inside of the absolute value, which is less than +1. What do I do? How do I solve for x? Well, I multiply both sides by 2. Okay, I can do that. And then I subtract 1 on both sides. So subtract 1, that's going to give me -3. Subtract 1, that's going to give me 1. And I'm left with this open interval. So if I were to draw that, it would look like this. From -3 to +1, I believe that is what I have. Now, what would be the halfway point between -3 and +1? What's the number that's halfway between these two values on the x-axis? Well, that would be -1. -1 is 2 steps away from 1, and -1 is 2 steps away from -3. Oh, look, that was the center value that I predicted at the very beginning. The center of this interval is at -1. Not only that, the distance between the center and one of the endpoints, whether it's this way or that way, is 2. So my radius of convergence is 2 when my center is -1. So with a center of -1, my radius is 2. That's how I figure out how far I can go on this x value number line to determine x values that will make it converge. However, I need to figure out what happens at the endpoints. So I go back to the original function, and we are going to substitute each of these x values. So what if x equals -3? So then I'm going to substitute a -3 wherever I see an x. And what if x equals +1? Well, then I'm going to substitute a +1 wherever I see an x. But I'm using the formula that is there. 2 to the n. I think I have that correct. Yes. Cool. Let's start with the right side endpoint. 1 plus 1, well, that's going to give me 2. And 2 to the n divided by 2 to the n is just 1. So really, I'm just left with this. Does this converge or diverge? Well, this is an oscillating um, sequence of numbers, right? Because I start with 0 I start by substituting 0 and I get 1, and then I substitute 1 and I get minus 1, substitute 2 and I get positive 1, minus 1, positive 1, minus 1, and this is divergent. So I'm not going to include x equals 1. Well, do I include this one? Let's see. Negative 3 plus 1, I believe that's negative 2 to the n. And if I combine these two, negative 1 to the n times negative 2 to the n, I believe that's positive 2 to the n divided by 2 to the n. Well, that just equals sigma of 1. And that is just 1 plus 1 plus 1 plus 1 plus 1, dot, dot, dot. And that also diverges. So therefore, I can say that my interval of convergence for this are only the numbers that are between negative 3 and 1, not including negative 3, not including positive 1. So my interval of convergence would be negative 3, which is less than x, which is less than 1. Not equal because we tested the endpoints, and then using the formulas and tests that we did in part 1 when we were looking at numerical series, we now know that that is not the case. That's how we find intervals of convergence. So we know that this is a power series that has a radius 2 radius of convergence equal to 2, and an interval of convergence specifically between negative 3 and 1. Woof, man, that's a lot of work. Okay, let's do one more, and then that's the end of this section. And then we're going to get into some Taylor polynomials and approximations. So let's take the limit as n approaches infinity of the absolute value x to the n plus 1 over n plus 1 squared divided by x to the n over n squared, but that's the same thing as multiplying by the reciprocal. And I want to make this less than 1 so that it will converge. Okay, let's go. I can reduce this with this, and I'm left with x to the 1. I cannot reduce anything here, so I'm left with absolute value of x to the 1 times n squared over n plus 1 squared, and that has to be less than 1. Well, that's the limit as n approaches infinity of the absolute value. Let's do the n's first. N squared over, and I'm going to go ahead and multiply this out, n squared plus 2n plus 1 times the limit as n approaches infinity of the absolute value of x, which is less than 1. This first limit is just 1 times the absolute value of x, which is less than 1. Oh, well then we're done. The absolute value of x has to be less than 1. That means negative 1 is less than x is less than 1. So if I were to draw this, I don't have to, but if I were to draw this, we're going from negative 1 to positive 1. What would be the center? Oh, the center is 0. So this is the center. This is the c value, center 0. What's the radius? The radius is 1. But what's the interval of convergence? For that, we need to check the endpoint. So we go back and we say, well, what if x equals negative 1? Then we're going to substitute negative 1 in here. And this is going to be an alternating series whose a sub n term is decreasing and it's approaching 0. So therefore, this is going to converge. And then what if x equals 1? Well, that would be sigma of 1 to the n over n squared, Well, 1 to the n is just 1. And when I look at this, oh, this is a p-series. This is a p-series where p equals 2. And if p equals 2, that's bigger than 1. That's going to converge as well. So both endpoints produce a convergent series. So therefore, my interval of convergence is -1 less than or equal to x less than or equal to 1. I now know that if I pick any x value between -1 and +1, or if I pick -1, or if I pick +1, any of those values are going to make this power series a convergent series. That's what we're looking for. Now that we have series that involve x values, we're looking to see what x values cause the infinite series to converge. In the next set of videos, we're going to look at some Taylor polynomials and how that is going to relate and connect to what we just did.